Okay, hi everyone. In this video, I'm going to show you how to show you a presentation on how to deploying an apple, banana, and orange recognition model onto your ESP32, and also how to train it and how to upload the data and find the necessary data. Okay, first of all, we need to log on into Edge Input and go into the data acquisition panel. In this panel, I have already uploaded some images, some data over to Edge Input. But to find the necessary data, you can use a web page like Kaggle and find the data like here in search, and then yeah, there's a lot of data you can find. So using the data, I'm using this data, we can then upload the data into our Edge Input model. The downloaded data, they have already split between test and training. So we just need to upload the corresponding files onto training test. Okay, next. Let's just check the import design. First input. Okay, you can see the 4 nodes in total. I'm gonna explain this quite simply. Is that first of all, we have an import that take the raw data, and in our case is that they are images, and then we need to extract the features from the images and from here, and then we use a learning block to classify our new data. So it's quite simple, and then I'm gonna explain a bit more about why I'm using the transfer learning images. Okay, so in deep learning, the most common uses of deep learning is to classify images. But to classify images, we need a lot of data to be able to do the task. We only have around 200 images, which is definitely not enough. We need more like thousands of images to teach the model to be able to differentiate from like an apple from a banana. But we can solve this by using retraining a previously trained model. Yeah, we call this method transfer learning. Okay, by using transfer learning, we can like fine-tune the previous trained model on our data. So yeah, by using this, we can train new models without a lot of data. Okay. Next, let's move on to the pre-processing feature generation. So besides resizing the image to a smaller scale, 96 by 96, in order to make the image smaller for our ASP32 to run it faster, we also need to turn the color depth of the images from RGB to grayscale. By applying grayscale onto the images that we input into the model, the files will be much smaller because the dimension would only be 3 times smaller. So by using grayscale, we can help to reduce the amount of final memory needed for inference. Okay. Next, let's walk over to the transfer learning. Okay, as you can see here, I'm using the MobileNet V1 with a size of 96 by 96, and I'm also using data augmentation with 30 training cycles. Why do we use the MobileNet V1, the smallest model? Is that because the smallest model? Is that because this model only uses around 50 kilobytes of RAM, and 100 kilobytes of ROM. So it will like fit perfectly onto our ESP32. But if we use like a different model, a larger and more and a better model, such as this one, use around this one, use around 1.2 megabytes of RAM and 2.6 megabytes of ROM. So it's not gonna work very good on our small device. So yeah, and one more thing, we also need to augment our data. By augmenting our data, I mean is that we can rotate, rotate by 90 or 120 to 120 degrees, or we can flip the image horizontally or vertically. And by doing that, we can diversify our dataset. Okay, after we finish training, and the training accuracy of this is not very good, not very high. Because I think that is due to the images being grayscale, while the images of bananas, orange, and apples are very colorful, like they are red, orange, and yellow. And one more thing is that the resolution is only 96 by 96, so it may be blur. Okay, so the accuracy is not good. For deploying, we need to use our Arduino library and the TensorFlow Lite model optimization. And we select the quantize in 8, select it, and then build. After that, we're gonna have this file over here. And to run it on our ESP, we need to here sketch, include library, and add zip library. After that, we can files, example, choose our custom library, which is here, ESP32 and ESP32 CAM to be able to run the model. The model downloaded from Arduino is only the model. It does not have the necessary code to run the camera, to use to transfer the image capture from the camera to transfer it to the model. So we need to use that. So yeah, here, this is the old one to run the model. So as you can see, so here, as you can see, the deprecated branch of this is that they are deprecated, and you can now use the example included straight onto the library, as you can see here. Okay, now let's test the model. Okay, let's first test an apple. Okay, let's test this one. Let's scale the image larger a bit. Okay, as you can see, the model are recognizing the apple. 90% accuracy. This is really good. Take this one too. Scale it up a bit. Quite good accuracy. Okay, next. Okay, now let us test the verifying an apple, an banana. Here's the banana. Okay, here we go. The banana accuracy is not very high. Yeah, let's test another one. This one. Let's test this one. Yeah, it's at best like 0.10, so not very good, not very accurate. Now let's just test the banana. The banana is also at around 30 to 40, not reaching 50. but it is recognizing the banana at least. So yeah, that's my presentation. Um, there is definitely things need to be improved. And if you have any question, you can leave them in the comments, or you can contact me via Gmail. Thank you for watching.